Yeah, let's take a look at the 9-10, and we're just going to be looking up for this first problem, looking up t values. And the t distribution is much like the z distribution. It's just saying what we do basically if we don't know the standard deviation. Okay, then how can we calculate some of these things? Okay, and so we use a t distribution. And if you go like to the bottom of the t distribution, and I'll kind of show you an example here, you know, and we're down, and remember our 95% confidence level. Hang on, I gotta pause. All right, so we were looking at the t table, and we were saying, you know, if you go down to the bottom, like at 1,000, and you see, you know, the 95% confidence level, like we talked about, and it always ended up being 1.96, and you can see it at 1,000 it's 1.962, and this means infinite, or what would be the normal distribution, then it's 1.96. So as you approach infinity, or bigger numbers of samples, right, then you get closer to the z values. But otherwise we can use the t values if we don't know the standard deviation. So that's all we have to do. So and for you guys, there is an appendix in the back of the book, and I'll maybe try to post this. I just found this one too, and I can post it as well. But it says use appendix B5 to locate the value of t under the following conditions. So the first one is the sample size is 12 and the level of confidence is 95%. Well, we've got to make one very simple adjustment, and that's page 293. It kind of explains that we've got to, if 12 is our n, we have to figure out what our degrees of freedom are. And it's just simple. The degrees of freedom is equal to n minus 1. So in this case, our degrees of freedom would be 11, and the level of confidence is 95%. Okay. And by the way, you can see the the 95 there. Okay, I'm sorry, corresponds down here. Oops. Yeah, I was a little bit goofy there. It's the 0.05. Okay, would be 95%. It's a two-tailed test in this case, right? Which means just like we did with those z's. Remember that we had to go back and we had to take the 99% confidence level and divide that by 2 in order to find the value. We're basically doing the same thing here. Okay, so we come down to our degree of freedom is 11, and our 95% confidence level, we should come up with 2.201. I hope I got that right, 2.201. There you go. B then says the sample size is 20 and the level of confidence is 90%. Okay. So our degree of freedom is 20. Okay. And we would use 0.10 then, 90%, two-tailed test, minus, so 1 minus 90% basically, and so we come up to 0.10. It's equal to the same as the confidence level down here on a two-tailed test, and I said it was 20, so we're at 19, so we should be 1.729. There we go. So far I've gotten them right. That's good. And the last one is the sample size is 8, so our degree of freedom is 7, and our confidence level is 99%. By the way, in your guys's, you'll see the confidence levels up on top. Okay, in mine it's down here. So we're at 0.01, 8 minus 1 is 7 for our degrees of freedom. So I'm at 3.499 is going to be my t value. Okay, what if I have two samples of 15 each? Yeah, that's kind of interesting. I don't know why I put that question in there. So maybe we'll answer that in another problem. But anyhow, page 734 is where you guys will find your appendix B5.